All right. Okay, so we're going to be continuing on with Unit 4. Today we're going to be looking at evaluating functions in Lesson 5 here. So we're going to look at function tables, and we're going to talk about and show independent and dependent variables here. So this says a function table shows which domain values the independent variable correspond to with the range values the dependent variable. Functions can be represented as an equation or a rule. Okay, so they might also begin with either y equals, or they might say f of x. Okay, so when you read this, you say f of x equals. Alright, and these actually mean the same thing. F of x is really just another way of writing y. Okay, both of these mean the same thing. They both stand for the y value in an ordered pair from the graph of a function. So remember, a graph of a function, so when we use the word function, we're talking about no repeating x values. To make a function table, either choose inputs, x values, or use ones given to you and substitute them into the equation for the variable x. Okay, so remember, this says f of x equals 2x minus 5. This is the same as saying y equals 2x minus 5. Okay, so we are going to plug them in and solve. That's what we're going to do here. So remember, anytime that we've been dealing with variables, we have been looking at them. So we are going to plug in the x value, and that's our input, and then we're going to get a y value. So if I plug this in, so I'm going to say y equals 2x minus 5, and I'm going to go across so that I have room. So now I'm going to plug in negative 2 in for this. So y equals 2 times negative 2 minus 5. Okay, so 2 times negative 2 is negative 4. So negative 4 minus 5 equals negative 9. So that is my y value is 9. So I'm only going to write y in one time. So I'm going to rewrite the equation for the next one. Y equals 2x minus 5 equals 2 times negative 1 minus 5 equals 2 times negative 1 is negative 2 minus 5 is negative 7. Okay, so let's plug this one in. Y equals 2x minus 5 equals 2, I'm plugging in x, which is 0, minus 5. Okay, 2 times 0 is 0, so 0 minus 5 is negative 5. Okay, and you kind of see what's going on here. As this one changes, it's changing every 2 because of that value in the front here. So it's going negative 2, negative 7, negative 5. Alright, so we can kind of see the pattern here. So let's continue and see what the pattern continues to be. Okay, so I'm plugging in 1 now. So 2 times 1 minus 5 equals 2 times 1 is 2 minus 5 is negative 3. And then y equals 2x minus 5. 2 times 2 minus 5 equals 4 minus 5, which is negative 1. Okay, so it says, let's start with negative 2. Which is what I just did here. Alright, so we don't read this because we actually just did that. We plugged it in and got our answers over to the side here. So that's what we are going to be doing. Alright, so let's look at the other side. Alright, sometimes you'll have to, choosing your input values, sometimes you'll be asked to choose your own input values. In this case, you should always choose at least one positive number one negative number, a 0, okay, and it says a total of 5. Just kind of like whenever we are doing our inequalities, we always had 5 numbers on our table. It just gives you a good representation of it. Especially if there is a fraction or division in the problem, some numbers will be easier choices than others. Okay, so for instance, like it says here, if you were looking at something like this, well, I don't want to choose 7, because if I choose 7, then I'm going to end up with a fraction. And I don't want to try to end up with fractions. I want to try to end up with whole numbers. So for this, because this is a fraction here, I would always choose a number that is divisible by 4, like it says here. Okay? It's easier to choose numbers, positive or negative. They're divisible by 4, which is the denominator. And that is why we went over divisibility rules. Okay? Denominator of the fraction. List 7 easy numbers you could use as inputs for the problem. Okay, so for instance here, we said 1 positive, so 4 would be 1, and 1 negative, so negative 4. Those are opposites. We always want to choose 0. Okay, 8, negative 8. These are examples. 12, negative 12. Okay, 24, whatever. There's no wrong answer for this. As long as you're doing it correctly and putting it in, especially when you get to choose your own answers. I'm just going to look and make sure that when you did it, that you are doing it correctly when you put them in. Okay, so those would be some easy ones. All right, I wouldn't say giving a number that is like 1,000. I would say trying to keep it close in value. So next part, let's look at evaluating the function. So solving the functions. So when we look here, evaluating functions means finding the output value of a specific input. If the function is written in function notation, so function notation is f of x, so remember that's y, then the specific input value is usually shown in the parentheses. After the f. Okay, so for instance, if f of x equals 3x minus 12, find f of 2. So f of 2 means when it goes in for it, we would be solving to figure out what it is. For right here, we would be plugging this 2 in for the x. Okay, so that means it means to substitute the 2 in for the x. So when that happens, so I'm going to write this here, 3x minus 12. Now I'm going to plug 2 in for x. So 3 times 2 minus 12. 3 times 2 is 6. Minus 12 is negative 6. Okay, sorry, that was crooked. But, so we want to plug it in. So this is our x value. So I plugged in my x value right here to get the answer. Alright, so graphing functions. Find in the function table, then graph the function using the values from the table. So we're actually going to plug this in. For this one right here, this is a different type of function. It's going to give, with this right here, the squared kind of tells us it's going to be kind of crooked like this, going up and down. Alright, and so I won't expect you to know too much, but I just want you to understand how to plug it in. So f of x, so I've got to find some x's, so I need 5 of them. Remember, we need 5. The golden number is 5 here, so that I have 5 points to plot. Okay, I always like to start off with 0. That's an easy one to plug in. So I'm going to plug that in for here. So I'm going to write it out here to the side. 1/2 x squared minus 3, okay, is equal to, now I'm going to plug in x here, 1/2 0 squared minus 3. Well, what happens to everything when you multiply it times 0? It becomes 0. So I end up right here, I end up with 0 minus 3, so that's negative 3. Okay, remember I want to find a number that is going to be divisible by 2, since 2 is my denominator. So I'm going to use just simple 2. So let's see what happens. 1/2 x squared minus 3 is equal to, now I'm going to plug in that 2, 1/2 2 squared minus 3. Okay, 2 squared is 4. 4 divided by 2 is 2, so I'm going to say 2 minus 3 is equal to negative 1. Okay, I'm going to do the same thing with negative 2. Alright, and I'm going to go ahead and write these down. I'm going to use 4 and negative 4 because they're close together, and it'll make it easier because I want to use something that's on this graph. So, when I plug in the same thing here, let's see what happens. But now, remember that this is why it's important for our squareds that we put our negative in our parentheses. Negative 2 times negative 2 is 4, because 2 negatives make a positive, remember that? So if I take negative 2 times negative 2, I get 4, because 2 negatives make a positive. So same thing here, I get 4 divided by 2, which is 2 minus 3, which is negative 1. So I still get the same answer here, but I have a different x value, so that's giving me a function. Okay, same thing is going to happen when I use the negative and positive here. I'm going to get that same answer, so let's see what that answer would be. Okay, so I'm plugging in 4 here, 1/2 4 squared minus 3. 4 squared is 16, because 4 times 4 is 16. 16 divided by 2 is 8. So 8 minus 3 is equal to 5. So I'm going to get positive 5 here, and I'm going to get positive 5 here. So now I'm going to graph that real quick. Let's graph it and see what it looks like. Okay, so 0, negative 3, 0, 1, 2, 3. Okay, and now I've got 2, 1, 2, negative 1. And then I've got negative 2, 1, 2, negative 1. And then 4, 1, 2, 3, 4. 5, 1, 2, 3, 4, 5. And same thing here, 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's going to kind of look like that. There we go. Alright, so that is how we graph. I know it's not going to be easy, but you know, if you have any questions, holler at me and I will help you.